Welcome to 2.7. As you can see, we got a whole lot of notes on here, and this is there may be another section later on in the book where I actually put my own notes in here. This section right here, this is the way the book talks about graphing rational functions, and that seems like less to know than this, but really you're going to get a very good feel for what I mean by these things. The 3-0 test. We're going to set the numerator equal to 0, the denominator equal to 0, x equals to 0. And this tells us what those do for us. And these will make sense to you. You will know these by the time you watch the video. And then we have the big X test, which we talked about the big X test quite a bit in the last section. And then freshman graphing is just t-charting. So I'm going to do every problem. I'm going to go through this process, talk about that as we go through. So there's no notes for you to put on here. In my opinion, you should ignore this. If you find this to be more helpful than what I do, more power to you. But I'm going to follow this structure that I've laid out, and we're even going to talk about the Mole Man. It's a registered trademark. Here we go. Let's take a look. So keep this close by for reference. 3 zeros. So step 1, I'm going to go numerator equals 0. Well, the numerator does not equal 0. There's I can't, like if the numerator was x plus 5, I'd say x plus 5 equals 0, x equals negative 5. We'll talk about what that does for us when we actually get the numerator to equal 0. And then denominator equals 0. Well, that happens when x equals negative 2. Now, at that time right now, we've talked about this in the previous section. X cannot equal negative 2. That implies that negative 2 is an asymptote. Take a look. If I put in negative 1.9999999, I get something like 10,000. It's 1 divided by 0.000001 or something. We get huge numbers. This thing's approaching infinity as x equals negative 2. Or as x approaches negative 2. Now, again, I want to make sure this negative 2 does not match negative 2 up there. You'll see that happen later on, but it doesn't right now. So that means we have a vertical asymptote at x equals negative 2. So I think I can get away with just counting by ones. Vertical asymptote. And then we just set x equal to 0. When x equals 0, I get f of x or y. Let's just do it this way. I put 0 in for x, and I get out 1/2. And the only reason we do that, I mean, because I could let x equal 1, x equal 2, x equal 3, and I might. But putting in 0, it gives us the x-intercept, and it's really easy to do. Take a look at 19. When we put 0 in for x, this is 0, 0, we get 5. There's going to be a point at 0, 5 on this graph. Okay, so really, really simple point to get. That's the 3x, or the 3 zeros right there. Numerator equals 0, denominator equals 0, x equals 0. Next, big X. The big X test gives us 1 over a huge number. That's 1 over, if x is a billion, 1 over a billion 2. It's virtually 0. That gives us y equals 0 as a horizontal asymptote. So knowing what asymptotes do, they suck graphs into it. I think my curve either is here or maybe down here, getting sucked into each of those asymptotes. Maybe something over here, maybe something up there. So what I'm going to do now, after the big X test, is just freshman graph. I'm going to pick some points. And you don't have to pick many of these. But I will tell you the ones that I would expect you to choose here would be negative 1, something a little bit to the right. Maybe negative 1, maybe 0. Like for instance, if I put in 0, oh, I didn't even put that point, 0, 1/2. We got a point right there. That came from that guidance. So maybe negative 1. If I put in negative 1, I think we can see real quickly. I get 1 over, sometimes I'll use scratch work over here. 1 over negative 1 plus 2, 1 on 1, we get 1. Negative 1 gives me 1. And you can put in as many points those as you like, but I'm just looking for a general feel. If I need an exact graph, I might go to my calculator. But if I don't have a calculator, I just want a sketch of what it looks like this. Now, it's important I tell you an easy way to lose a point on a 10-point graph on a test. Know exactly what you're doing, but just be careless and let this slide away from the asymptote. Don't do that. Don't let this pull away from the asymptote up here. If this pulls away from the asymptote, not only does it tell me maybe you don't know what asymptotes are doing, it also makes me think that, do you even realize this is a function, because it ceases to pass the vertical line test. So if you get so close you get on the asymptote and you have more to draw, just keep it right on the asymptote. That is better than letting it get pulled away. All right, 19 going to be similar. I'm going to go through 21. Oh, I'm going to go through 21 with you here. Let's see, that looks good. Actually, I'm going to go through 23 with you and leave the other two, because 23 has a little bit of a change to it. Notice each of these ones has, I'm getting caught up here. Each of these ones is linear. We have just an x to the first, x to the first. So let's go ahead and jump to 23. I'm going to jump around and just pick a few problems on here to do. So here we go. Step 1, numerator equals 0. When the numerator equals 0, we get y equals 0 on negative 4, we get 0. So if I put 0 in here, we get 0. Denominator equals 0. Well, that happens when x equals, add 4, take the plus or minus square root of. Plus or minus square root of 4 is 2. Now what we need to do here, please pay attention to this because it's going to pop up, but not for a little while. We need to see, does this match this? Remember from last section, if these match these, then we have a hole in the graph, because that gives us 0 on 0, and that's like the worst thing that can happen in math until you learn calculus. So that's just a hole in the graph. But what this one now tells me, so now that these don't match, here's what I can do. I put in 0 for x, I get out 0. So it gives me this point right here. And the denominator can't equal 0, so those are our vertical asymptotes. Negative 2 and x equals 2. And then x equals 0 does not give me new guidance because I've already got x equals 0 here. Put in 0, get out 0. So that wasn't helpful to us in this case. All right, let's go big X. The big X test, the 4 becomes fairly insignificant, and we get f of x, or y equals x squared on x squared, and that is just 1. Y equals 1 is our horizontal asymptote. Okay. All right. And then we got some freshman graphing to do, but here's where Mole Man really comes into play. Watch this one. This graph can only be 0 when the numerator is 0, and the numerator is only 0 at 0. In other words, if I got mole men that live above the x-axis, or no, mole men live below the x-axis, and street people live above the x-axis, the only place they can visit each other is through this little manhole cover right here. There's no other place we can go through the x-axis, which I'm going to tell you, here's what I know this means. The curve is up here, this curve is up here. I'm not sure what happens in the middle in here, but I know we're up here, we're up there. But let's go ahead and confirm that with our freshman graphing. Here's points that I think for sure you would want to put in there. I'm going to go to 3. If I, rats, so bad, x, y, I'm putting in 3 for x. If I put in 3, I get 9, on 9 minus 4, 5. So that's 3. There's 5/5, 10/5, 9/5, somewhere right in there. So you can put in more points, but that really gives me guidance what's going on if I understand that asymptotes just suck the curve into them. Don't let it pull away. I'm going to be picky about that. I promise you, people are going to get minor deductions because they just carelessly let that curve pull away from an asymptote. If I put in -3, look what happens. Same as putting in 3, and that's a discussion we had earlier in this chapter. This is an even function. It looks the same to the left as it puts to the right, so I get 9/5. -3 gives me 5/5, 9/5. This graph looks like this. Now, please listen closely. It is possible. See, the horizontal asymptote is about what happens when x gets big. We go way left or way right. It's really about what's happening out here and out here. It's not really about what's happening when we're close to 0. The graph could actually cross that asymptote. Our possibilities are like this, kind of a U shape going up or a U shape going down. I can tell you, I know it must be a U shape up or a U shape down because it's an even graph. But you get a graph without knowing that, it could be any of those. So I would expect you to put 1 in. Let's see what's happening at 1. Put in 1 and we get 1 on 1 minus 4, -3, -1/3. And we've learned if I put -1 in, I'm going to get the same thing. Is it possible this graph could come down then pop back up here? What part of mole men don't you understand? We can't cross through the x-axis. We just come up, peek our head out, and head back in. It's like the Groundhog Day. There's a look at our graph. Now I do feel compelled to do one more of these problems on this page. I know that's out of the ordinary. Usually I'm doing just half of them. But I'm going to go ahead and do one more of these. I'm going to go ahead and do 19. Numerator equals 0. We get 5 plus 2x equals 0. X equals -5/2, which means I think there might be a point at -5/2, 0. I think there's a point here, but I have to wait till my denominator is 0. Denominator equals 0. That's when x equals -1. I check and see, do they match? Is there a hole? No. So now I can take care of those. I have a point, -5/2 turns this fraction into 0, gives me that ordered pair, and this is a vertical asymptote because the denominator cannot be 0. So a vertical asymptote at -1. Okay, when x equals 0, I get 5 on 1. Put in 0, get 5 on 1, get 5. And that's the point we talked about earlier. All right, well, I got 2 guidance points for me. I've got a vertical asymptote. Big X test, 5 and 1 become insignificant. Y wants to look like 2x on x when x gets big. That's y equals 2. That is our horizontal asymptote. So mole men, if we're talking mole men, we can only pass through here. I know I'm not, it doesn't look like this. I am certain that we're up in here even without that guidance point. Let's get a couple points on here just to see how we're going to look. There's one value absolutely I would think you should have in here, and that is -2. Let's put -2 in. We get 5 minus 4, 1 on 1 minus 2, -1. We just get -1. So -2 gets me -1. Let's let the asymptotes go to work. You can get more guidance than that. You want to put in -3, you want to put in -4, that's fine. But we look something like that. Maybe we, this is kind of far away from the asymptote. Maybe we should put in 1 here. I put in 1 and I get 5 plus 2, 7 on 2. 1 gives me 7 halves. 2 halves, 4 halves, 6 halves, 7 halves. So we look like this. And I'm not going to let it pull away. Keep it going toward the asymptote. Don't let it cross, but keep it going toward it. And there we go. So I'm only leaving you 1 on that page. There's a quick view of Eric Clapton. You have 1 problem left there. I suspect that's going to be pretty quick, but you might have questions. Let me know how I can help.